I would like to introduce you to our moderator today, Florian Kolb, Chief Commercial Officer and General Manager of Energy at Intertrust, a Silicon Valley-based global leader in data collaboration, digital rights management, and securities technologies. Florian is responsible for all of Intertrust's product sales and business development activities, as well as the company's initiatives in the energy and related industries. Before he joined Intertrust, Florian spent 5 years as CEO, Managing Director at Energies, now E.ON, Silicon Valley's Innovation Group, where he led U.S. strategic investments and innovation activities. He also helped incubate internal startups at Energy. Before coming to the U.S., Florian worked for RWE AG in operations, restructuring, as well as M&A, driving large-scale mergers and acquisitions in the European energy sector. So without further ado, I will hand over to Florian, and let's get this started.
Yes, hello, good afternoon or good morning, wherever you are. We are based here in California, so thanks for having you. I see like we have 25 people in the meeting, so congratulations that you joined this meeting today. It's a bit of a, what you would think a hardcore energy and energy system topic, but I think we will discover throughout our talk that it's actually not that technical, but really very important for the decarbonization mission that supposedly also the US will be on pretty soon. I mean, given the remarks of the incoming administration to rejoin the Paris Climate Agreement, this is like very relevant, and also this topic is very relevant in that context, and we will explore that throughout our talk. I will, before my colleagues here, Amit and Mark, will introduce themselves, I will give you a bit of an overview of how we will run this. So we have actually 3 rounds of questions that lead us to the topic. So we will discuss initially a little bit what are actually microgrids and what's going on, what are they, why are they relevant, and also what is their contribution to decarbonize the energy system, which is very important because actually there's something going on like climate change, which we all have to fight, and microgrids will bring an important contribution to this battle. And then after we are done with the questions that I have to the guys, we will lead over to you and open the mic for questions and answers. So that's the protocol. I think we have around 45 minutes. So we will manage time accordingly. So yeah, we have 2 great speakers, Amit from AutoGrid and Mark from Schneider, who are really distinct experts in this area. I had the pleasure to work a couple of years also together with Amit. I did an investment in his company. So this is like a very exciting combination. So Amit, would you like to say a few words, introduce yourself before we go over to Mark?
Yeah, sure. Good afternoon, everyone. Thanks, Florian, for having me on the panel. It's a real pleasure to be here and speaking to all of you. And just my background, I'm a founder and CEO of a company called AutoGrid. We are based in Silicon Valley, about 100 people. Started almost 10 years ago now out of Stanford University in Palo Alto. And we have been working on applying software, especially what we now call AI, to optimize energy systems. And at a very high level, I mean, the energy systems have been all about deployment of capital, deployment of building out more infrastructure. But as we will discuss during the panel, a lot of effort is now going towards optimizing the assets which are already on the ground. And so our company provides real-time optimization for both utilities as well as project developers who are building microgrids and renewable power plants, and helps them optimize and maximize the return on investment of capital that they're making in these projects. Mark, you want to go
Thank
next?
you. Mark, short intro?
Hey, good afternoon. Great to be here. Thanks to ACG for hosting this panel, and a pleasure to be here with all of you today. My name is Mark Feasel. I'm the president of Smart Grid for Schneider Electric in North America. Schneider Electric is a $30 billion multinational company headquartered in Paris, France. North America is our largest zone by revenue. You may, if you don't know us by the name Schneider, you may know us by some of our brand names. So we are the leader in energy and power distribution and automation. So Square D company with respect to low voltage electrical distribution. APC, American Power Conversion, is one of our brands. Invensis for process automation, building automation, Andover Controls, TAC. So many different industries. I focus on specifically two things. It's our electric utility segment in North America. I'm accountable for that. Electric utilities are seeing big changes in their business model. Energy efficiency, demand response, distributed generation, and storage are changing how they collect revenue and what that revenue streams look like. And on top of that, the edge of their grid, where they interface with the customer, is becoming much more complex. What used to be a one-way grid with passive consumers is now a multi-dimensional grid with energy flowing in all directions, creating a very interesting technical problem in addition to the business model and regulatory challenges that they face. In addition to leading our utility business, I lead our microgrid business in North America. So this is the story of those consumers beginning to look at energy in a new way, leveraging digitization of their energy infrastructure and of their processes to think about how they interface with utilities differently, how they consume energy, and what some of their needs are. I began my career in the United States Navy, Naval Nuclear Submarine, did that for about 4 years, and went to the University of Toledo.
Awesome. So probably there's something to talk about a nuclear submarine and to which extent that is already a microgrid. Great, guys. So I will start with Mark. Mark, how do you guys at Schneider Electric define microgrids? Lead us a little bit through. I mean, what's a normal grid and what's a microgrid? Please.
Yeah, absolutely. So, you know, the Department of Energy has a pretty good definition that I think we mostly try to use. And it's an integrated energy system consisting of interconnected loads and a distributed energy resources, which can be controlled as a single entity, operated in parallel or intentionally islanded from the grid. And so if you unpack that a little bit, essentially it's the story of co-locating generation and load, and in doing so, recognizing some of the improvements and resilience that can happen when you get rid of all those wires and poles and other things in the middle, and also the story of the efficiencies that can be gained by eliminating all the losses associated with the transmission distribution of it. But microgrid, we see as something that's more than that, because microgrid is the story of digitizing energy infrastructure and has a profound impact on the consumer. I mentioned the fact that consumers have historically been passive, and it's because it's very difficult to grasp what, the nature of electricity. As we apply data to energy infrastructure, we start to begin to be able to operate differently, and a microgrid becomes something else. It becomes the point at which the intersection between energy that's generated locally, energy that's smartly procured from a utility, and the efficiency of consumption. Historically, those things have been separated. They were three completely different processes within a consumer. Normally, someone in procurement would be negotiating rates with a utility, ensuring that they're on the right utility tariff, paying the bill, et cetera. And then maybe you'd have an operational person thinking about getting efficiency out of whatever their consumption was. And then finally, maybe there is a sustainability officer that's thinking about adding some distributed generation, maybe solar to improve the carbon footprint, or maybe it's someone in operations thinking about a backup generator. But those were three different processes, not very integrated. Microgrid integrates those things, and in doing so, creates new outcomes.
Very good. And why do you think that microgrids are an interesting opportunity?
Yeah, I think, we are on the cusp of a major sea change. I mean, it really began about 5 years ago, but this is really the story of digitizing that energy infrastructure, taking this commodity that's invisible, dangerous, and travels at the speed of light, which is electricity, and characterizing it in such a way. So I like something that the National Renewable Energy Laboratory says. They say that it's the story of decommoditizing energy. So you've got this commodity that is difficult for consumer to understand. As we digitize it, we create situational awareness for a consumer. And when you have situational awareness, you can begin to automate. And when you do that, you can dissect that kilowatt hour or BTU into more fundamental and more business relevant context. And that is energy cost, not just the bottom line what the cost is, but how predictable is that cost. The second vector is sustainability or carbon footprint. And the third vector being resilience. So in the old world, you procured a kilowatt hour from the utility and you got whatever mix it was that they provided. In the new world, you look at your business, you understand how cost, resilience, and sustainability contributes to the commitments that you've made to your shareholders, your customers, your employees, and you define a solution that achieves those. And generally the solution involves using a microgrid. That literally was nearly impossible to do for most consumers just 5 years ago. There are a few different reasons why. It was very difficult to take renewable energy assets, deploy them behind the meter, and have them work in parallel with other energy sources. Renewable energy like wind and solar is intermittent in nature. There's technical complexity associated with combining that with other fossil fuel-based like diesels were a common solution. But high-speed data communications, solid-state electronics have created a scenario where in real time, we can allow those things to work together, either in combination with the grid or isolated from the grid, and achieve those balanced outcomes of resilience, sustainability, and cost. So the advance of technology, and along with that, massive decreases in price in renewable energy, solar panels dropping, and of course, the battery energy storage, which is important in this world of taming this intermittent resource to go do that. So the time of this is just beginning. There's some exciting things I think we'll talk about later, business models and regulatory changes that are unlocking more of this. So it's important because the time is now to go and embrace this technology.
That's very fascinating because I think for a lot of people, the electrical energy still comes out of the power plug and that's it. So when I spent 15 years in the utility industry, I mean, that was the sentiment of most of the people outside the company I was faced with. So a lot of people don't really see, what's behind the plug. And you described very well, there's a lot behind the plug. Let's move over to Amit. So Amit, you're a real software guy. And I know that, you have done amazing things for the energy management of chips and so on. Why are you now involved in microgrids? That's a real question for me.
Yeah, well, I don't think I have to explain to this audience here that software is eating the world, and that's true for, I think, many domains. And I definitely think that that software is playing a very critical role in microgrids and energy transition in general. As most of you know, the electricity system, the grid that we have designed over the last 100 years is one of the biggest sort of engineering achievements of humankind. And it has always required very sophisticated software to operate and manage for managing generation, dispatching, scheduling, managing the transmission and distribution. Now, as the grid is transforming, as the energy systems are transforming, this paradigm is becoming of managing these systems is becoming even more challenging. Not only do you have your power coming from renewable sources, which are intermittent, the wind may not blow all the time, the sun doesn't shine in the night, as well as a lot of these generators are now owned by customers. So whether these are in the microgrid settings, in a commercial or industrial facility or rooftop solar. So the conventional command and control paradigm of managing these assets where you could just tell a generator and put more fuel in it and dispatch it doesn't work anymore. So now in this new world where you have literally millions of these new types of generators and new types of assets, and very granular sort of changes that are happening. You need sophisticated software, which utilizes all the advances that we have seen over the last 20, 30 years, and more recently in the last 10 years around big data and AI to squeeze the most out of these new investments that are getting made and to run the system more efficiently, reliably, in a resilient manner. So that's where we come in, and we are trying to bring some of these technologies to make our power systems more efficient. Great.
So you said software eats the world, but before you start eating, what challenges from a software and from a data perspective do you have to overcome, especially around microgrids?
Yeah, no, I think it's probably, I've been in software all my career, and before doing energy systems, I was, as you mentioned earlier, I was in the semiconductor industry and designing software to optimize these complex chips, which have millions of and billions of elements and so on. And so when I came here, I thought that maybe this is going to be an easy system. Like on a chip, you have tens of millions of transmission lines, while like if you look at the US electricity grid, I mean, there are only 200,000 or so transmission lines. It turns out that this is a really, really complicated problem. I think there are many dimensions of what makes this challenging. One is that it's a very heterogeneous environment. You have many different types of assets, many different types of OEMs. You want this whole system to be extensible, plug and play. As I mentioned earlier, the generators behave in a very different way. You can't just add more fuel and make them run. You have to sort of predict when the generation will be available, how much will be available, and do it in a much more granular manner. I think the other big, so just dealing with that data fabric, how do you sort of keep track of what's happening on the overall network, and how do you then take action to make sure electrons get exactly where they are needed, precisely when they're needed, just in time. I mean, this is the ultimate just-in-time system. You press a switch and electrons show up, and it's better than Uber, right? You don't have to wait for even 2 minutes to make this happen. And in the past, a lot of this was done by building overcapacity on the generation side, and you have these backup generators that run just for the eventuality that somebody wants to like put an electric kettle or something and brew tea. So now when you have renewable, that paradigm doesn't work anymore. You have to make the system more efficient. You can't put a megawatt of backup power just for a megawatt of solar panel, and it's just not practical. So that's one, just the data governance, data visibility, and then dealing with that amount of data. I think the other problem is around just sort of business models. As I mentioned, the traditional command and control paradigm doesn't work anymore. So every time you have these microgrids or these customer-owned generation, you have to somehow get into a transaction with the utility of some sort, whether it's a project developer who is providing it energy as a service, or your traditional utilities, and sometimes multiple parties who have to be involved in this. So that's again adds a lot of complexity because it's a multidimensional problem, as you said. Everybody needs to have access to the data, and how do you make sure that that all the transactions are flowing through? And frankly, the grid was never designed for this invertible sort of reverse transaction. You have big power plants that produce electricity and they supply electricity to end consumers. Where the utilities were buying from a few generators and then selling to a lot of different consumers. But when you flip it around and you say now instead of 1 gigawatt power plant, I have 200,000 5 kilowatt solar panels, and as a utility I have to buy power from these systems, that is a completely different order of magnitude in terms of scale and optimization and transaction capability that you need. So that creates a lot of challenges. And then finally, I mean, unlike a social media system, which obviously, I mean, is mission critical for a lot of people, it's still not mission critical to the extent that that power systems are. So the reliability, resiliency, security, I mean, that becomes super important, and it's obviously a target for a lot of nefarious activities and disruption. So how do you run the system in a very secure and reliable manner? That is again something which makes this problem super interesting, super challenging, and it's definitely unlike anything I had seen before I sort of got into this space myself.
Great. Yeah, I think you mentioned the point, reliability, and you turn the switch and then the power flows. I mean, what comes to my mind is power outages. And apparently, if we look to the availability of power also in different parts of the world, you know, some countries are doing quite well. Japan is doing very well. Germany is doing very well. I have to say that you can sense from my accent that I'm a German, but it's also fact-based. There's around 7 to 12 minutes of power outages. Well, the United States has some challenges there where I think we have like 100 to 200 minutes of outages. But I think the outage discussion is an interesting topic because, you know, if we go outside, we see the poles and the wires, or in Europe, you don't see so many poles and wires because a lot of the cables are underground. And that actually leads me to the second round of questions where we want to dive a little bit deeper. And I want to ask Mark, so when we have this resilience issue and, you know, we have this complex asset system, what contributions can now come from microgrids to advance and also improve the electrical energy system?
Absolutely. So I'm going to take it back even one step before we get to resilience. And that is, you know, there's still almost 1 billion people without any access to energy today, right? And we believe that access to energy is a basic human right. Microgrids will be a key technology in leapfrogging the existing centralized generation, distribution, transmission story to bring energy to places in the world that it's not at today. So, you know, absolutely key and catalyst to bring that energy. But for the rest of us I should say, in addition to the 1 billion that don't have energy, there's 1.5 billion around the world that have access to only intermittent energy. And so this is worse than power quality. This is like every night we're turning off energy from 10 p.m. to 6 a.m. or something like that. So obviously microgrids, a key technology to being able to solve some of those scenarios, especially building upon what I talked about before, the increased efficacy of solar energy and other energy sources that can be co-located, you know, with load very well. But then you get the rest of us, right? The rest of us that are connected, you know, to the grid today, using energy in a way. And Florian, you mentioned that you know, we're energy in such a way that we're doing permanent damage to this planet. We've got to think about how to decarbonize how we use energy, and that's going to be a few different things. It's going to be converting from, you know, straight fossil fuel utilization for some processes like internal combustion engines and convert those things to electric. But it's also going to be the story of more renewable energy coming onto the grid. And microgrids have a very important role to play there too. So as we talk, you know, in the resilience here for a moment, you alluded to the fact, you're right. There are, you know, within North America, you know, outages anywhere, you know, measured in hundreds of minutes in many places. Increasing in severity. So several great studies show the impact of outages. I think an important thing to understand is outages mean a very different thing today than they meant even 10 years ago. You know, our world is interconnected in ways. We depend upon these cloud services in ways that we never have before. And one small example, after the public safety shutoffs occurred last year to minimize threat of wildfire in California, there was one scenario in which, you know, when they did the rolling blackouts, that communication towers went down. And of course, do you think the public safety officials and firefighters, you know, are running around with laminated maps like we used to 20 years ago and logs to fill out what's going on? No, they didn't, right? They're using Waze, they're using Google Maps, and they're using these cloud-based tools, which of course stopped working because the power outage resulted in the comm towers going down, and it was a cascading issue. That same thing's occurring in healthcare today, more healthcare moving from robust, resilient environments to the home or these small clinics. You know, whether it's some sort of in-home in-home dialysis, right, is something that's starting to proliferate. So impacts of an outage are very different than before. Thinking about how to harden those scenarios, those nodes, microgrids play a very key role in being able to harden very specific nodes on the grid in a way that is indeed cost effective. You add that then to the story of the sustainability that's unlocked when we think about bringing a more sustainable world, being able to accommodate more renewable energy resources. Microgrids and associated battery energy storage play a key role in taming that intermittency.
Yeah, I mean, that was like my second question. So the role of microgrids for decarbonization, I mean, you mentioned it. So can you explain a little bit, how this will enable more wind and solar? Because they do a lot of wind and solar today. They just connect it to the centralized grid and that's fine.
It's true, and certainly grid scale resources remain very important. What I'd ask you maybe to consider is, you look at this idea of, what is energy going to be doing over the next 2 decades, right? So most studies say that energy utilization in mature economies per capita and per GDP dollar is going to remain flat, right? Because we're getting more efficient, right? We're doing more efficient things in residential, commercial, industrial, all throughout the entire value chain. However, electricity consumption is going to double over that same time period. So essentially, we're going to be converting processes today that use fossil fuel directly into electricity. So what are some of those processes? Well, we've alluded to one of them already, the electrification of the transportation segment, which of course a lot of people think of as internal combustion to electric vehicle, which is a big chunk of it. But the truth is it's more than that. It's airports and seaports, right? Electricity used to move people and to move freight around. It's on a seaport, unlocking the ability for ships to come in and shut down, not burning number 6 fuel oil sitting right off the port of LA and belching those emissions in the city, instead shutting down. And so, how are those loads going to be fulfilled? You're talking in a shipyard, 5, 10 megawatts a piece, right? Having a localized energy source to be able to do that increasingly of a decarbonized fashion, so solar, et cetera, is going to be very important. So transportation segment's going to be one area. Another big area is going to be indoor agriculture. This is an area that, we increasingly see urbanization, see food deserts being created. You see these, scenarios where indoor agriculture makes a lot of sense, uses 95% less water, no pesticides, but there's an electricity requirement. These things, by the way, are not trivial. So, some of these indoor agriculture areas are 5, 10, even 25 megawatts, one we recently worked on. In many cases, these are in urban environments, in repurposed facilities, sometimes old malls or some factories. And generally, the energy infrastructure required is not even present. So even if they could take service off the grid, it can't be done very easily without a significant upgrade to the grid. Microgrids can make a lot of sense, especially in that example where the heat created, let's say, from a distributed natural gas unit, along with its CO2 emissions, actually help the plant-based environment. So another interesting angle, microgrids likely to fulfill that. Another big area going back to the transportation segment a little bit, when you think about these nodes of EV charging, once again, you're going from maybe a place that had very little electrical infrastructure to now requiring many megawatts, something that without massive upgrade of distribution feeders is going to be very difficult and expensive. Microgrids make a lot of sense to do that. So I think you look at these areas of incremental load. You look at people putting that incremental load on. Do they care about sustainability? Let me think. EV people that are going to buy EVs, probably yes. People that put indoor ag in, probably yes. Right. So generally looking for more green energy. And a microgrid can be a great way to achieve that given the existing grid constraints. Not that it'll happen without bulk scale investment, of course that's going to occur, but in order for it to happen at the pace it needs to happen, it's probably going to happen microgrid first.
Yeah, I think that's a very great perspective. And I mean, one of my favorite topics these days, what we call sector coupling, where energy-wise you combine the electrical energy sector with the transportation sector and also the heating and cooling sector. and you make all the input energy from renewables. So it greens all these three sectors, but that requires an energy exchange between the sectors. And people are discussing also to use hydrogen for that, or for example, existing gas pipelines that can be retrofitted for hydrogen. And it sounds like microgrids also have a very important role in that context. Amit, so you see all the data and you get all the data, and data is insight. So what use cases from a data perspective do you see for microgrids?
Yeah, I mean, I think Mark touched on this quite a bit. I mean, from a use case perspective, I mean, I think the three primary drivers at the highest level for the customer or the end user of electricity are really around resiliency. I think that's becoming important as we are seeing more extreme climate events. I mean, California, where we are, PG&E is doing their best to help the microgrid business case, as I say, with all the power safety shutoffs that they have to do. And I think that resiliency is really driving a lot of microgrid development in North America, I would say. But then, of course, there is a much bigger push towards sustainability. I mean, and again, Silicon Valley companies are taking the lead in this. A lot of companies have announced aggressive goals, not just to wipe out, not just to sort of become carbon zero, but wipe out their entire carbon footprint from, like Microsoft announced this, where they want to wipe out their carbon footprint from since they were incorporated. And then finally, I think there is the cost element. Today, it is not a trade-off anymore to actually put a microgrid. The return on investment that we are seeing in California, for example, is very attractive. It's like in the double digits, sometimes more than 20-25%. And if you add subsidies, it can be even more. So at this point, I think that there are pockets in the world and where the business case is sort of self-sufficient. And of course, I mean, it does require proper optimization. So that's where we come in. Like if you have a very naive sort of system, then the return on investment on that capital may not be as high as what you can do with an optimized system, which is optimizing both the customer side of the benefit and then also use the assets and rent it back to the grid to provide grid services, as we call them, defer investments in peaker generation, transmission and distribution networks, and so on. So if you do all of this, many parts of the world, this is not just a North America phenomena, but even if you go to Asia, for example, I come from India, where a lot of companies have their diesel backup power plants. The system is unreliable, and all the diesel generators fire up right after the power goes out. And there now just the OPEX of diesel is more than the CAPEX and OPEX of renewables. So a lot of customer-driven microgrids are happening in all of Southeast Asia, including India and other places. Africa, of course, Mark talked about off-grid microgrids as well. That's a completely different use case for places where the grid is not yet there or it's extremely weak. And so we are seeing all of this. And I think the key thing from a data perspective is to how do you make the system very sort of easy to deploy, right? You like, given that there is so much variety in the types of microgrids, whether it's in the campus or it's in a industrial park or in a home, you don't want the deployment of your software to be very project specific or site specific, because you have to deploy this at scale at thousands, tens of thousands, hundreds of thousands a site, and deal with that variability, right? So how do you make these systems which are self-learning so that they can very quickly understand what the specific context they're operating in, and then can squeeze out the maximum value by fine-tuning the algorithms for that particular building or particular site. And this environment is complicated because, I mean, these a lot of these use cases are still a microgrid operating in a environment where it is grid connected. So again, you have to deal with the rest of the system, and then you have to do your own optimization while making sure that the overall system as a collection of these microgrids and as well as centralized assets is running efficiently and in an optimized manner. So that's where a lot of action is happening. I think right now the #1 market is North America for microgrids, but I at least in our experience, Asia Pacific is the fastest growing market, and we are seeing a lot of zero subsidy projects that are now getting funded, and it's coming, it's in the money. And I think every year as the price, it's the classic sort of Moore's law type of a cost reduction that we are seeing, maybe not as steep as what we see in semiconductors, but a good 20–30% every year. So more and more regions are coming in the money, as I say, where without subsidies you can deploy these microgrids.
Yeah, you mentioned I think 20% IRR. So my question, right, where can I invest?
Yeah, exactly.
It's a little bit like the
rush.
Sounds a little bit like the Schneider equipment is getting cheaper every day. Yeah, that was a joke, by the way.
No, it's becoming more valuable.
Amit, you touched already a bit that optimization seems to be very important. Can you lead us briefly through how that works from a tech side? So, and really try to what are some of the mathematical exciting issues so that people get a bit of sense actually how sophisticated this stuff is?
Yeah, well, I mean, so it's sophisticated at a number of levels. One is just the sheer volume of data, as I mentioned. If you do the math and see how much data are we getting from these assets like batteries, where you have many channels of data coming in at a few seconds each, 24/7. This becomes a very interesting system just from applying big data techniques and so on. But then once you start looking at the other sort of big thing is how do you forecast what's going to be your generation, what's going to be your consumption at a very micro level, right? So in a microgrid context, you may be forecasting every building, you may be forecasting every home. Even within a home, you're forecasting the solar generation, you're forecasting how the consumption is happening. And eventually you have to make sure that the demand and supply is balanced at every node on this massive network. And the variability is now much more localized as well, because a cloud cover may pass over a particular sort of very targeted area, and suddenly the generation of solar will go down. So just understanding what's going to happen in a few hours, in a few minutes, in a few days. That depends on weather forecast. So there is the whole weather modeling, which is very interesting. And then applying those weather forecasts to understand how the system is going to operate. And again, it's an economic system as well as a physical system. So you have to forecast not just how the electrons are going to flow, but how prices are going to change in various markets. So that creates a very rich AI and machine learning problem, which is core to understanding and solving these challenges. And then finally, the scale of optimization is unprecedented, right? So if you look at the power systems today with centralized power plants, in the whole of North America, you have about 10,000 generating units. These are like gigawatt scale plants. I think for those of you who understand the energy markets, there are various ISOs, independent system operators, and RTOs, which manage these generating units in most of the United States. So, and to manage this, they use supercomputer class machines and very sophisticated hardware and software to keep the system running. Now, when you look at the same problem from a distributed asset perspective, a 1 gigawatt generator, which is large, but it's only one single entity from a data and optimization perspective, gets translated to 200,000 small 5 kilowatt rooftop solar plants and batteries. And so we are talking about 2-3 orders of magnitude more, and that's just the starting point, more optimization. And this is a very, I mean, from a mathematical complexity theory perspective, it's an exponential problem in the sense, I mean, the most general formulation is what we call a mixed integer linear program, which is a NP-hard problem, which means that with the number of assets, the complexity of optimization grows exponentially. So, so typically these systems, the algorithms that are out there, they sort of work up to a few hundred to a few thousand assets. They don't really, and even as I mentioned, for that, you have to throw a lot of compute power at it. So if you want to do it 2-3 orders of magnitude more complex optimization, that requires a completely new paradigm of optimization, decomposition, partitioning, and so on. And so that's again a very rich and open area right now. I think we are just beginning to scratch the surface of this. And I think as you get more and more assets, you are going to see the complexity truly explode.
That's probably also why some companies like your company and also the company I'm working for, based here in Silicon Valley, tap into this know-how and into the expertise that is needed to crunch these amounts of data. Or actually, whether it's like social media or energy, data is data.
Right.
Doesn't really matter the ones and the zeros. What's behind it? Yeah. Very interesting. So I think that describes very well the status quo. Now, in round 3 of the questions, we want to look a little bit ahead. And I have like a killer question for Mark. Will microgrids replace centralized grids over time?
Yeah, I think the short answer is no. We will certainly see microgrids playing a larger role. Microgrids being leveraged by consumers to bend energy to their will, to the needs of their business. But yet there will still be large parts of the grid that are going to be required to be serviced by a mutualized energy source. I mean, it kind of goes back to the 1930s when the cooperatives were created, right? They were created because it didn't make financial sense to run for publicly owned these companies that primarily that were city based at the time. I think I recall, like in 1935, only 10% of homes in the country had access to electricity because it didn't make sense for the companies operating in cities to run these long wires out and do it. And so, thanks to some, federal act that allowed farmers to band together and form cooperatives, by 20 years later, 90% of homes in the country. And so this, the problem persists yet today. There'll be some parts of the grid that will move quickly where it makes economic sense, and there'll be others where it simply doesn't. And so, I see the need for, distribution system operators to, directly serve some of those loads, but beyond that, to provide a key role in orchestrating what might look like a federation of microgrids to achieve things that are in the best interest of everyone.
So that's actually good news for the people that like the centralized grid. Other than grid people, in my 15 years in the utility industry, I've never met someone who actually is interested in the grid or likes it, or like a lot of people don't like their utility, which has to do with the customer experience they get and also the bills they have to pay. They typically don't understand. That's helpful. So, where is this microgrid thing in 5 years? I mean, what will Schneider provide in 3 to 5 years, if you can talk about that?
Hey, look, there's always, when you think about evolution of a market, there's always 3 things that have to occur. They occur in parallel. You've got, the technology to unlock some change. You've got the regulatory environment, the rules in which you have to operate. And then you have the business models. Can you put something together in which you have people incentivized to do something to move a market forward? So you have to align all of those things. And it's pretty clear to most, I would say the market in general, the benefits of digitized, decarbonized, decentralized energy, right? It goes back to those things we talked about: lower cost, better cost predictability, better carbon footprint, better resilience. So that's pretty well understood and accepted. And that's been, an educational process that's been occurring over the last, 5 years with case studies and references, buildings, et cetera. Probably the reason we're all here today is because we at least think there's some value in doing that. However, there have been significant hurdles in the way. Let's imagine that you own a campus right now, and in the old world, you wanted to, expand a building or add another building. Did you call up your utility and ask them what kind of generator they were going to buy and where they were going to site it and how many poles and wires are going to be required and how they're going to operate it and where they're going to get fuel from? No, of course not, right? You simply said, hey, I need about 800 amps at 4,160 volts. And they said, okay, we'll go back to you. They come back and they say, great, we'll be able to serve you, get that in for you in, in 6 months. And, it was an easy button. But in exchange for that easy button, you gave up the ability to prescribe the carbon footprint resilience and cost structure that made sense to you, right? And so in the new world, if you're going to think about embracing the microgrid, someone's got to account for those questions. Should I use solar, combined heat and power, both? Should I use a turbine or reciprocating engine? Do I need a battery? What kind? How big? Where should I site it? Will I be allowed to interconnect all these assets? Who's going to control that? How long will that take? What incentives and rebates are available to me? Will I be able to monetize them even if I know what they are? Where am I going to get the money? What's the IRR going to be? How much it's going to take to operate it? What if something breaks? These represent technical, regulatory, and financial questions that most consumers just aren't prepared to answer and haven't been. So the industry has been working very hard, and Schneider Electric working very hard as part of that, to either eliminate or transfer those risks. Some examples of that, are, working, Schneider Electric working with partners like, Amit, right? Working with companies that can solve these technical problems better than can be accomplished something on site. So a lot of times that's abstracting that complication or risk from the site to the cloud, making what happens at the site something simpler. Within our manufacturing environment, it's 10 years ago, 5 years ago, you wanted a microgrid, a box shows up of solar parts and inverters and transformers and wires, and someone had to install it on site and take an outage and connect it and test it out and all these things, right? Well, that's a complicated process, an expensive process. Leveraging advanced manufacturing, being able to do more and more of that in the industrialized environment where you've got quality control in place and all the spare parts you need and all the people trained to go do those things, and all the sophisticated tools like hardware in the loop and other kind of sophisticated modeling that have been developed over the last 5 years. We're able now to create a device, and we launched a device called the Energy Control Center that literally is almost a microgrid in a box. It's been simplified to the extent that we had to do a startup in Hawaii about 2 months ago. And instead of having to jet a bunch of Schneider engineers over in the middle of COVID land, and expose the site and our employees to risk, able to simply ship a pre-tested, pre-configured microgrid over that was able to be installed by a local partner and commissioned remotely. So you can imagine what, that's going to be able to do to reduce costs. But the third evolution, you still have the financial questions. So technically we can get rid of some risk and transfer that risk to others, but there's still the interconnection questions and the regulatory questions. The emergence of business models like energy as a service are absolutely critical. And that meaning simply that standing up essentially a bespoke company that builds a mini utility from the load out to deliver as an outcome, sustainability, resilience, and cost, making it literally just as easy as calling up that utility and getting what maybe you don't want, but you're going to get anyways. In an energy as a service world, you're prescribing the outcomes you want, building a company to go deliver that to you, that company taking all of those risks and simply delivering a price per kilowatt hour. So we've stood up 2 companies over the last year on that. Alpha Structure, a joint venture between Schneider Electric and the Carlyle Group, one of the largest private equity companies in the world, doing major infrastructure in that fashion, such as JFK Terminal 1. And then just 2 months ago, announcing a new company called Green Structure, which is designed at much smaller microgrids, modular, scalable, repeatable microgrids. In that case, partnering with Huck Capital to really focus on 10 megawatts and below, which represents 90% of all energy consumption in commercial industrial buildings. So we see that those things, the technology that abstracts risk, the business models being a massive accelerant, and a market that measured within the next 5 years in 10 billion, tens of billions.
That's a good outlook. Let's do a quick time check with Yvonne. Should we move to Q&A?
Yeah, I just posted for people to, if they have questions, to please put that in the chat window or let us know that they have questions and then we can call up on them. So if you, for now, want to continue, that's great.
Okay, let's give
Is there anybody
people
who has a question?
a few minutes for questions to any one of us. Let's see if some questions are coming in.
Go ahead and speak now. Am I up?
You have to unmute Robert.
Well, while Robert is unmuting, I have a question, if that's okay. This is Frank. So great presentation. I definitely learned something. This was great. One of the things I'm puzzled about is pricing. So I understand the whole carbon footprint thing. When the guy knocked at my door to sell me solar, my daughter made me buy solar at. Can you hear me?
Yes.
Okay. My daughter made me buy solar at the time, but now I'm always puzzled. I'm basically getting money back from. I'm getting money back from the.
Yeah, no, it was muted.
I'm getting money back. So how do you arrange pricing across all this?
Well, I can speak to that at a high level. When you think about your all-in energy price, I mean, there's a volumetric price per kilowatt hour that is highly dependent upon where you live.
Right.
Levelized cost of energy varies widely across the U.S. As you may know, that there is no federal energy policy. It's state by state, and therefore all the nuances that happen in state government, along with specific transmission, distribution, and constraint issues, result in pretty massive price differences from anywhere from 4 to 5 cents a kilowatt hour in some parts of the country to north of 25 or 30. So that certainly is one fact, one aspect of it. The second thing is that there is an increasing growth of time-based pricing, and this has to do with how utilities are looking to recoup sunk costs in their grid without raising the per kilowatt hour prices. So this is, of course, the emergence of demand fees, but also system peak fees, et cetera. And in some cases, like Ontario, those system peak fees, called the global adjustment, represent up to 70% of the total energy expenditures you have from electricity. And so essentially putting stability can allow you to minimize or even avoid some of those fees, and in some cases produce energy for less than you're buying from the grid. And there's one more important facet that solar and wind specifically have no marginal fuel cost, so they can create predictable energy costs over very long periods of time because you're not trying to calculate that in some way.
Well, do you need the OPEC of energy of electric energy then, which kind of arranges the pricing? Because when I overproduce, which I sometimes do, and I give back to the grid, I'm looking at my bill, I'm actually getting much less back than what I pay, right? So, and I think now you have this at a much grander scale. So it feels like you need kind of almost like the OPEC for electrical pricing.
Well, as part of the story there is, understanding what does that look like, and how do you monetize excess production? In many places, it doesn't make sense to send any energy back. It makes sense to store it instead and leverage it, during other parts of the day. So there's different regulatory and technical constructs that go into that. But the energy as a service business model, part of that entire design is to manage that for you. So you don't necessarily need a central OPEC, which there really never will be based upon the regulatory nature of our grid, at least in my opinion. But instead, looking at a kind of a site-by-site story and energy as a service can represent one mechanism to allow someone to do that for you.
We have a question here from Sergey. Let's move to the next question. Amit, if you would start the company today in this space, what would it be?
Well, I mean, I frankly have asked this question many times myself, and I still personally have a bias towards software-driven business models. And I think that we are still in the very first innings of how these energy systems are going to get managed now. So personally, I think just having an asset-light model, like especially if it is a venture-backed company. Now, of course, if it is it's not a venture-backed company, there are many different models that could make sense. But if it is a venture-backed company, typically like something that can globally scale, do something. I mean, of course, software can't solve all the problems, so you do need project developers and people who can actually do complicated implementations. Now, I think the challenge there is like, how do you get to scale? Because I mean, once you get into project development, then it's a game of scale and and capital, right? So if you have a way of finding low cost capital and you have an easy way to scale, then you can do something. But I personally think that is a business which is more suited for larger corporations like Schneider and others who are very sort of entrenched in that world. Now, of course, I mean, there is always innovation happening and there is always collaboration possibilities. But given that we are in Silicon Valley and software is eating the world, to my original opening statement, I'm definitely thinking that there are a lot of opportunities around that, especially around management of EVs and electrification of transportation. I think that's a very, very rich area of energy systems.
I agree to that. We have a question from Bob. Bob, the mic is yours.
Yes, this is Bob Lopresto. I'm president of an HOA in Saratoga with 110 owners, and we've been trying for a year to get reassigned to a grid next to us, which is downtown Saratoga. We have no transformers, wires, poles in our property. We're all underground, and we've written letters to the top 6 executives at PG&E, and we've got no answers. Does anyone on the panel, especially Mark, have an idea of who we could go to try to get this simple reassignment? So we've had 2 power shutoffs, and we're trying to prevent them in the future.
Well, that's a tricky question. That's going to fall into the realm of regulatory policy. One of the things so the public utility commissions at the end of the day are going to be able, they set the jurisdiction, but then there's myriad local issues below that. I would say, not knowing the nuance of that specific area, but you could think about talking to your local state representative. At the end of the day, the PUCs and others are accountable, to that government. If you can't get a response out of anybody, I would maybe start with your local state representative and see if they could help you triangulate into, someone either in a municipal level or in the PUC that could help connect you.
I understand the PUC has an advocate program. Maybe that's where we start.
If you can get into that, yeah.
Okay. Thank you so much.
So here's Sebastian. He has a question for myself. Thank you very much. Florian, what activities do you see today in data collaboration in the energy space? To me, it seems like asset owners are reluctant to share data because of privacy concerns. This hinders data scientists to develop performant models. Well, it seems like Sebastian has looked at our website, because the company I'm working for is trying exactly to solve this problem. So we provide data technologies like data virtualization, identity and access management, and secure execution environments where data can meet code in protected environments. So the data isn't exposed to the code owner, and the code owner doesn't expose its IP, intellectual property that's embedded in the code, to the data owner. So to bring to have an intermediate technology in between. And what we are seeing, so we have big utility shareholders, and I mean, they are moving slowly, but the good news is they are moving. And people understand that, availability of data is a very crucial thing, and trust and security drives availability of data. And you know, everybody talks about machine learning, AI, and all these things all day long, but without data, it's not happening. And what you also can't do, you can't go into like a big utility and say, look guys, you have all these legacy systems, rip them out, put a data lake in place, and then you're off to the races. I mean, people will tell you, look, our regulator doesn't allow this cost to be put in the regulated asset base, so we are not going to do that. So you need to have technologies that provide a thin layer on top of what's there that enables trust and security, and then makes the data flow more easily and provides people also the comfort. So, I mean, what we are doing, you know, we are trying to work together with the industry, with the utilities, but also with companies like Schneider to see, you know, what stuff can be done and what can be offered to people that provides this level of comfort. And this is a problem. If you talk to the guys at Stanford, they have the same problem. They want to do research, but they need data. So they get some data here and there from some generous data donors, yeah, but it's a real problem. Or if you run startup programs, yeah, the startups, they need access to some data. And how do we organize that? I think it will be a crucial thing for innovation in the space moving forward. So that's my answer. The colleagues are nodding. That's good to see. We have another.
So let's do one more and then end the event, because we're a little over already.
Yeah. What do you see alternative energy future in auto or transportation market for both industries and consumers? That's a question from William. Who wants to take that?
Go for it. I can take it. I mean, I think we touched upon it a while in various questions, but I do think that that's probably the single biggest opportunity that exists. And I mean, apart from the fact that this is the intersection of two multi-trillion-dollar industries, I think the impact on the society. I always, I mean, a lot of people look at EVs as electrification of transportation, and it's a car which has a battery. But if you just flip it around and say, now I have a battery which has wheels and it can go anywhere, I think it unlocks a whole new dimension of optimization that can be done and create value. And I think each one of the use cases on their own, if you just have a battery, you can make money with it, even if it was parked in a particular building. And if you have a car, of course, that creates enough value just as a transportation resource. But if you can double dip and say that I have these vehicles who can provide grid services and benefits as an electricity resource, storage resource, and continues to provide transportation at a lower cost, I think it's like, it's a gold mine basically. So I think this is going to see a lot of very rapid, I think, adoption. And of course, Schneider is one of the leaders working in that area. We are doing a number of projects, both with utilities as well as fleet owners, operators who are now moving to electrifying their vehicles.
Yeah, and a closing remark, a car with batteries is also easier to operate and to handle than a nuclear submarine. Thank you very much. I had to make that last point. Thank you very much, guys. This was very educational, at least for me. I hope for the audience as well. It was great having you. Thank you very much. Yvonne, back to you.
Thank you so very much. It was truly educational, and I can only imagine what the future holds in this. And we'll have to have you back in a couple of months to see how this space has changed. So thank you to everyone who joined us today. Thanks to the panel, Florian, Amit, and Mark. And have a great day, everyone. Stay safe, and we'll see you soon.
Bye-bye.
Thank you, everyone. Pleasure. Bye.